that you did in lower classes like 62. One-to-one function. A function is a one-to-one function if each value of x corresponding to exactly one value of y and vice versa, right? Meaning there's no repeated x or y. And how do I check if the function is one-to-one by graph, vertical line test, or horizontal line test? Horizontal line test, right? So if the function is one-to-one, and you draw any arbitrary horizontal line, it should cut the graph at most once. Vertical line test, testing for function. If the function is one-to-one, then you say it has an inverse, and vice versa. If they say the function is has an inverse, it's gonna be one-to-one. Right? Those are always go together. One-to-one function, sometimes I just say 1-1, or I write 1-1, meaning one-to-one. Is a set of order pair x, y, and the inverse of f of x denote f inverse of x is a one-to-one function that contains the set of all order pairs yx. You start out with xy. If f has the inverse, then its inverse is yx, meaning what? They swap domain and range, right? They swap domain and range. Now, for notation wise, this right here, it is not 1 over f of x, okay? I know the notation is confusing because usually when, say, I give you a to the negative n, you would rewrite it as what? 1 over a to the n, right? Right. But this is not the case. It's not it. It's not had nothing to do with the reciprocal. It's just the coincidence of notation. So it is not equal to 1 over f of x. We say f inverse of x, but not f to the negative 1 of x. So again, if the f has inverse, then its inverse is have their inverse and there's domain and range are swapped. In mathematics, we can write like this. F of x is equal to y, and f inverse of y equal to x. You look at the function, the original function, the input is x, the output is y. But for its inverse, the input is what? Is y, but the output is x. That's one domain and range swap. And one more piece, if you graph f and f inverse, they are symmetric about the line y equal x. Let's take a look at this one. Find the domain and range of f of x. So the one you see in black there is f of x. What is the domain of f of x? Where does it start and where does it end on the x-axis? Where does it start? No, very good. Thank you. -5 to 2, right? Domain is all your x values. So the function, if you look up on the x-axis, it starts at -5. Is -5 included? Yes, right. Solid dot mean included. Right. So start at -5, include -5. So bracket all the way to 2, include 2. So another bracket. What about the range? Where does it start? From bottom top? Yeah, from -3 to 5. Does a graph represent a one-to-one function? How do I check? Remember I said about horizontal line test. So you just draw an arbitrary line like that, and it's appeared to cross the graph only once. So yes, it is one-to-one function. Sin This passes the horizontal line test, HLT. If it 1-to-1, then it has the inverse. Can I sketch the inverse? Can I sketch the inverse? Yes, all I have to do is what? I know the points. I know some points for f of x. All I do is just swap them, reverse them, right? So instead of having -3, -5, -3, it's gonna be -3, -5, -3, -5. How's your red? Right here. Instead of -2, 3, gonna be 3, -2. 3, -2 will be here. And 2, 5 becomes 5, 2. Connect them together. That's your inverse. This is f inverse of x. And it's symmetric about the line y equal x. Sorry. What is the domain of f inverse? Where does it start? Start from -3 to 5, right? -3 to 5. And what does it end? I'm sorry. What is the range? What is the range?
-5 to 2.
Yeah, thank you, Mike. -5 to 2. Look at that, it's swapping, right? Domain of f is the range of f inverse. Range of f is the domain of f inverse. To verify two functions are inverse, instead of keep graphing them, which is not reliable, okay? We're gonna use algebra to prove if two functions are inverse or not. So here is your procedure. Do you guys remember composite function? That you put one function inside another function. If I can show that f of g of x is equal to g of f of x, and both of them are equal to x, then I conclude that g is the inverse of f, and then f is the inverse of g. What do I mean by that? If I were to put the function g inside the function f, and the outcome is x, and then I do the same thing, just reverse process. If I put the function f inside the function g, and the output is also x, then those two functions are inverses. Let me show you in with example. Let me highlight f of x with blue and g of x with red. So I need to prove two things, right? I need to prove that when I put g of x inside f, so g of x is the inside function now, my result should be what? Should be x. And I do the same thing, just reverse. If I put f inside g, my outcome also x. Then if these are true, then I conclude that f and g are inverse of one another. So let's prove this. There are two processes I have to do here. Let's do the left one first. What is g of x? When I highlight in red, right? -8/5 x plus 16. So I'm going to replace g of x with -8/5 x plus 16. So that's okay. That's your g of x. What do I do with -8/5 x plus 16? I plug that blob, I call that the blob. I plug that blob for f. Right? So remember what f look like. F is -5/8 times x. Well, it's no longer x, it's going to be times blob, right? Times something big plus 10. And that something is -8/5 x plus 16. Negative 5/8 times negative 8/5 is 1. That is x. Negative 5/8 times 16 is what? 16 divided by 8 is 2. 2 times negative 5, negative 10. Then bring down that 10, so plus 10. Negative 10 and 10 cancel. I have just x. One down, one more to go. Why don't you tell me what to do for the second one so I know that you understand it? What's my first step? Write g, which is outside function, and you replace f of x with negative 5/8x plus 10. That's f of x. And now you're going to plug that negative 5/8x plus 10 into g. What does g look like? G look like this, negative 8/5 x, or no longer x, I would say time blob, right, plus 16. You can fill in that blob with negative 5/8x plus 10. Negative 8/5 times negative 5/8 is 1, so x. Negative 8/5 times 10. 10 divided by 5 is 2. 2 times negative 8 is negative 16. Bring down that positive 16 as well. So the final answer is x. Is f and g's are inverse of one another? Yes, right? Good. They both equal x. So your conclusion, since f of g of x is equal to g of f of x, they both equal to x. Thus, f and g are inverse of one another. Done. So if I give you two functions and ask you verify they are inverse, that's your procedure. Any question? This is a review. You're supposed to remember this. It's from 62. Now, what if I only give you one and I ask you to find another instead of verifying? So that's different process, right? What if I give you one? I give you f of x and I ask you find me f inverse of x. Here's all the steps. I'm gonna go through the step while I'm doing the example. So given f of x equal x cubed minus 5, my first step is replace f of x with y if necessary. It's gonna be y equal x cubed minus 5. Step 2, you interchange variable x and y, meaning you swap x and y. So it's going to be x equal y cubed minus 5. Remember, you only swap x and y, not the whole thing, right? So keep everything in the same order. The only thing you move is x and y. I see students do this. I see students move the whole x cubed on the left and move y here, which is wrong. So don't write this down. This is what I don't want you to do. It's wrong. Just x and y. Leave everything as is. And step 3, you're going to solve for your new y. Now I'm going to solve for that y. Add 5 both sides. X plus 5 equal y cubed. How do I solve for y? How do I solve for y? No, solve for y.
You said solve for y.
Yeah. Right now I have y cubed.
Don't you cube both sides?
Yeah, cube root both sides, right? So cube root, not cube, that is what you meant, cube root both sides. The cube root and the cube cancel because they inverse. Oh, I forgot to put the little cube here. Little index there. When you do cube root or fifth root, like odd root in general, you don't put plus and minus like you do in square root or even roots. Right? And your last step, you replace y with f inverse. So write everything the same, just replace y with f inverse of x, that's all. You're done. All right, so that's reviewing. Do you have that on your exam? I don't think you do much, but you need to understand it. You need to understand. Now, the question is exponential function has an inverse? Remember, exponential function is what? Let me recall for you. Y equal a times b to the x. Does it have an inverse? You know, let's just do b to the x. Let's just make it very, very basic. If you look at the graph, don't draw this. Don't draw this. Well, you can, but you don't have to. If you look at those, that's the exponential growth, right? And then exponential decay, look like that. If you look at them graph, those are exponential graphs. Can you conclude to me whether the exponential function has an inverse? Can you tell me if they have an inverse? You don't have to find one, but you tell me whether it has it or not, that's all. Yes or no? Yes, because it passes what test? How does all test, right? So yeah, it has an inverse. Well, if it has inverse, how do we find it? We're gonna kind of use this process, kind of. I'll tell you why I say kind of. So the first step will be replace f of x with y, right? And then second step, you do what? You swap x and y. So step one, you replace f of x with y. Step two, you swap x and y, so x equal b to the y. And step three, you solve for y. But how do I solve for y? This is special. Usually y is in the base, but now y is all the way to the top. How do I bring that y down? Well, lucky for us, the inverse of exponential function is called log. So what I'm going to do is take log base b both sides. You know how you take the square root both sides? Kind of like that. You take log base b both sides. Why do I choose base b? Why not base a, base c, base d, right? Why it has to be base b? Remember what I told you, if two functions are inverse of one another, what happened when you shove one into another? They equal to what? They equal to x, right? If you put one inside another, they equal to just the one letter x. B to the y and log babies are inverse. This cancel, so y drop. According to the property of inverse function. So that's cancel. So all I have is log base b to rewrite the left-hand side of x equal y. And this right here That is the inverse of f. In short, if I give you b of x, the inverse of b of x is log babies of x. Right? Let me give you I never test you with definition and explanation. I give you problem you solve, right? So let me give you an informal definition of log. This is all you have to remember for this, at least the one thing you remember for this slide. Log equal exponent. Does this make sense? I'll explain it to you why it makes sense. This is your exponential function. The one I highlight in black. And I have what? And for the second line, for step 2, let me rewrite step 2 without the log thing. The step 2, I have x equal b to the y. Right, that's step 2 before I take log both sides. What is y in that equation? Y represent exponential, right? Yeah, y is exponential. What happened when you take log both sides? Log equal y. Log equal exponent. That's all you have to remember. Really. Forget about this. Forget about that. Well, you have to understand it, but it all comes down to log equal exponent. So very important. I put a little star there. All right, let's convert between exponential and log form. If I have convert exponential to log. So this question I want what? I want log. So let's do that. So log equals something. Log base something of something equals something. Right? So remember what I said, log equal exponent. Right? So on the right hand side, what should be equal to? Which one is the exponent on that equation? The 2, right? The 2 for the base. 2. So log equal 2. So first thing first, you'll be able to write that. What is the base? 4, right? 4 squared, so the base is 4. So you write subscript 4 there. Well, the 16 has nowhere to go, but it had to be here. As long as you remember log equal exponents, you can fill in the rest. Let's try the second one. You have a bunch of these questions on the exam. Usually most students get this right. Again, log equals something, and fill out one thing at a time. What is the exponent here? 3, right? 3. So log equal 3, and base, well, 10 to the third, so base is 10. And 1,000 has to be here. And then number 3. Logs equal. Why don't you tell me what I should fill in? Equal what? Go ahead, Kobe. Yeah, base.
Base of x.
And then the middle number will be √3, right? That's it. So you got the jig, right? And then last one. Log base. The power. I'm sorry. Yeah, the power is -3. Base is 10. 1/1000. And it makes sense. You can check whether you do it right or not. I call this a tornado arrow. 4 square equals 16. 10 cube equal 1000. X to the 1/2 equals square root of 3, which is equal to the original problem, right? And then last but not least, 10 to the -3 equal 1/1000. So you can check. And that tornado arrow, you're going to use that to convert from log to exponential. So here I want exponential. Use that tornado arrow. 4 cube equal 64. So this equivalent to 4 cube equals 64. Is 4 cube equal 64? Yes, right. So you know you're doing the right thing. X to the 4 equal 81. You do 4 root both sides, x equal 3. But no, we're not going to solve, so we just leave it like that. We're not solving, we're just converting. Oh, I forgot to say this. If I don't put a base for log, it's going to be understood as base 10. Right? It's called common log. Can someone tell me the exponential function for this one? Let me show you. What's my exponential function? I give you a tornado, so the tornado arrow should be what? Well, what's the base? What's the base here? Base 10, right? So it's gonna be base. And remember, log is exponent, so -4 gonna be the exponent. 10 to the -4 equal 1/10,000. Did I put 100,000? No, 10,000. I fixed it. Makes sense. Is 10 to the -4 equal 1/10,000? Yes. You doubt yourself, you can check this. It's 1/10 to the 4. It's 1/10,000. Last one, we'll be done with that converting thing. 1/2 to the x, make sure you put parentheses like that, equal 1/8. Is it easy enough? You're gonna have one page of exam just converting back and forth like that. You're not solving, just converting. Yet, not solving yet. All right, let's talk about the graph of logarithmic function. For me, if I don't have a graphing calculator, it's easier for me to graph the exponential function first, find the points, and then swap x and y. Then I can graph the log. Say I have the red one is exponential function. 0, 1. The inverse of exponential function is log, so 0, 1 become 1, 0. And then you can pick more. Okay, you can pick a bunch of more. You can pick this point on the exponential function, this point, this point, this point. Actually, I think I have a, see if I have decimal. Oh, right here, I do. So I start out with the exponential function like that. And that's its table. I pick a few points. Right? Now imagine I don't know what the inverse function look like, but I know the table for the f, right? All I do is just what? Swap x and y. So I got a few points, right? If you do more, you can get more. Now if I would have traced along those points, my inverse look like that, which is your log. And it is true because it is symmetric about the line y equal x. Like that. So this one is f of x equal, that's f of x equal 2 to the xa. And this one is going to be f inverse of x, which is log base 2, because 2 to the x of the base is 2 of x. Can you tell me the domain of the red one or the blue one? The domain of the red one is what from? What does it start? The domain is x value, right? Start from negative infinity all the way to positive infinity. Imagine just drag that arrow to infinity. So f of x is red, which is negative infinity to positive infinity. What about the range? The range, what does it start? Well, not one, hopefully nobody say one, right? Because I do go down from one. I just never cross the x-axis. I get close to it though. They call the horizontal asymptote. So from 0 to infinity, that's your range. Not including 0, so use parentheses. And now the inverse. For the inverse, either you look at the graph or you can just swap domain and range from the f. And it makes a lot of sense. Look at the domain of the blue function. It starts from 0 to infinity. 0 to infinity, right? And then the range will be bottom top be negative infinity to positive infinity. I don't think I'll be finished this lecture today. It's a long lecture. All right, natural log. Why they call it natural log? Because you see it a lot in nature. Natural log has base e. So I give you natural exponential function. Remember that's last time? Y equal e to the x, remember that? What's e equal? Roughly 2.718, something like that. So correspondingly, I have natural log, right in red. Is gonna be log base e. I don't use log base e a lot. I use ln. L log n for natural, natural log. So log base e is the same thing as ln. Okay. The common log, we talk about this, is equivalent to log base 10. Again, I usually don't write the 10. If I don't write it, you be understood as log base 10. So that's okay. I know there's a lot of bookkeeping before we actually do a real problem, but you can understand all that. Let's solve some log problem. we're gonna use the informal definition I told you, log equal exponent, and that tornado arrow. I want to solve this. I want to solve for x. Unfortunately, x is in the base. Right? It's special. If I want to solve a log, my best chance is to convert it into exponential. So use a little tornado arrow. I have x squared equal 49. Square root both sides, plus and minus. X equal plus minus 7. Am I done here? Can I box my answer? Am I done here? Now x equals, so this imply what? This imply either x equals positive 7 or x equal negative 7. X equal positive 7, no problem. Can I take x and negative 7? Can the base be negative? No, right? Remember base what? B has to be positive and it cannot be 1. Remember that? Okay. That's your extraneous solution. Extraneous is fancy way of saying extra solution. So your final answer is x equals 7. The reason being because x is the base. Yeah. From the last lecture, we say base cannot be negative and it cannot be 1. It can be between 0 and 1 though. Remember between 0 and 1 you have exponential decay, right? Bigger than 1 you have exponential growth. I forgot which one I give you for the extra credit. I think I wrote on there. So x cubed equal to, I want to solve for x, so root both sides. When you take odd root, you don't need plus and minus. So you're done. Why don't you guys do number 4? I'll walk around, see how you do. At least write the equation into exponential equation form. That's the least you can do. But if you don't know how to solve it again, write the equation like it's a point, at least a point. If you put the fantasy around 1/4, the x applied over 1 and it's okay. It take practice. It take practice. So everybody get this. I see 1/4 on the left, and I see 64 on the right. Let's do the easiest one first. 64 is the same thing as 4. If I would have converted into base 4 cubed, right? How would I convert 1/4 into base 4? If I flip 1/4 into 4/1, what happened to my exponent? It changed the size, right? I can do this. 4 over 1 to the negative x. Do you remember that? We talked about this last time. And vice versa, right? If you want to change b over a of negative to the negative n, you flip it, it becomes power. 4 over 1 is the same thing as 4. So 4 to the negative x equals 4 cubed. It's an equation, 4 to the negative x equals 4 cubed. The base is the same, then in order for the equation to be true, the exponents have to be equal to each other as well. Right? So this negative x equals 3. Basically, he's kind of, I don't want to say drop the base, it's wrong to say so, but let's just say that. Okay, let's just say you cancel the base. It's not the right way to say it, but that's your final answer. It takes practice. There's many techniques. You can check. Put negative 3 for x. 1 over 4. Don't write this down. To the negative 3. It is indeed 64. Right? You can put negative 3 here. Negative 3 become positive 3. So 4 cubed equals 4 cubed. So check. Did you guys write the second one, number 4? Can you read it for me? I see some of you did it. Tell me the equation. Just the equation, not solving. I saw some of you did it. Yeah. Yeah, go ahead. Yeah. 2 to the first is 2. This linear should be easy. Okay, so 5x equals 1. X 1/5. Then you check, it is check. So those are easy log equation. You see more complicated one later. This one, if you know, if you're not accustomed to log, is to ln, you rewrite it as log base e. So that's ln. That's power right there is ln. And then rewrite the rest e to the 4x equal 8. If you want, you can put the parenthesis around the input. I call this the, in mathematics, the right way they call the argument. Whatever inside the parenthesis for argument. And then the tornado arrow, right? E to the 8 equal the argument. So e to the 8 equal e to the 4x. Again, I'm saying this, it is wrong, but I'm just gonna say it, maybe it's intuitively help you to solve it. So that's imply a equal 4x, x equal 2. From 5 problem, what is your conclusion? What can you tell me when you solve log? What do you do the first thing first? You change it into exponential. Right? Change exponential. Another tip for you is that you should have one term on the left and one term on the right. Always. Right? If you have 2 terms, you somehow you kind of figure out the way to combine them into one term. You cannot just leave it 2 terms and try to solve. Bless you. Bless you. Yeah. Did you see the extra credit on the Moodle? Can you check it for me? Let me see what it looks like. You might not be able to do it yet. I'll extend the time. I'll extend it till next time. If you want to, you can try this. All right, I'm going to, let me see what I'm gonna do today. I'm going to finish the basic property. And then the inverse property. And hopefully, if we have time, we finish this slide and then that's it. Right, that's it. Okay. All right, 3 more slides and then we're done. Up to 3. If 1 o'clock, I'll let you go. So basic property. Before so that is 2 property, basic property you're gonna see. Let me give you an example. How do I come up with that property? If I say log base 13 of 1, what the right hand side should be? Do a little arrow thing. 13 to the what power? Give me 1. 13 to the what power? Give me 1. 0, right? So the right hand side should be 0. Another example. Log base 24 of 1 equal same deal, right? 24 to the what power? Give me 1. 0, right? Even ln of 1, I claim is also equal to 0 because, let's be explained, because of this, I can rewrite ln as log base e, right? And then bring down the 1. E to the what power? Give me 1. That was 0. ln e is 1. So as you can see, if your argument, when I say argument, I mean the input, the 1 inside the parentheses. When your argument is 1, it doesn't matter what base you have. The right hand side is 0, right? B to the 0, remember any number to 0 is 1, right? So B to the 0 is 1. Log babies of 1 equals 0. So that's the first basic property. Now move on to the second one. So if I have log base 12 of 12, 12 to the what power? Give me 12. Arrow in black. 12 in the what power? Give me 12. 1, right? 12 to the first equal 12. One more. Log base root 3. So base 3 of root 3. So root 3 to the what power? Give me root 3. Go to the 1. And one more. You tell me. Log base pi of pi. 1, right? Pi to the first equal pi. So log base b of b, if the base and the argument are matched, your final answer is 1. So you can remember when I cancel the, remember this, go back up here, back the very beginning. See, I cancel the one in yellow ball. See that I cancel because equal 1, right? And then the y drop down. You're supposed to remember this. If you don't, so at least understand it so you don't have to remember it. Right, inverse property. Almost there, almost there. I'll let you go soon. If I have log base 2 of 2 to the x, well, what it should be equal to, then I have 2 to the what power equal 2 to the x. X. Another one, if I have log base e of e to the x, same thing, you can do a little arrow thing. E to the what? Give me e to the x. Well, x. Let me keep my arrow in black. I keep forgetting. Do it again. Remember, log base e is ln, right? So I can write like this, or ln of e to the x. Remember what's ln e? No, I didn't write it there. All right, it's equal 1, equal x. It's the same thing. ln is something log be. So ln and the e cancel. Log and the e cancel. So if I have log baby as b to the x equal x, this is a general form as opposed to that one. Right? That is a special case when x equal 1, right? When x equal 1. So when x equal 1, you have b log baby is a b to the 1 equal 1. That's special case. One more. This one is harder of the 4. If I have 3, and then I raise to the power log base 3 of x. You gotta remember what I say about inverse function. When you put one function inside another, they cancel, right? What's left is just x. Or what's left is just whatever the input in the parentheses is. So there's same thing here. I put the log function inside the exponential function. Remember, this is your power, right? 3 to the blob, right? And that blob is a log function. And they are inverse of one another. They cancel. So that just equal x. One more example, if I have 10 raised to the power log base 10 of, say, x plus 1. So now my argument is no longer x, it's x plus 1. Remember, this is 10 to the sum power, right? 10 to the blob. And the blob is, fortunately, that's a log function, which is the inverse of the exponential. They cancel. So equal x plus 1. Short, if you have b raised to the power of log babies of x, as long as the base are matched, as long as you have the b's here, it's not so dark. As long as you have the b's here and the b's here that match, then you can cancel them. So it's equal x. One more, and maybe I'll let you go. One more. We can do inverse property next. E to the ln of x. E and ln are inverse, right? So they cancel, equal x. It takes practice. Don't memorize it. Well, if you memorize it, good for you, but I want you to understand it. If you do more homework, you automatically kind of know it. I never remember this. Just kind of know when you do more. All right, we continue next time. I'm gonna let you go.